Right, next question number 5. That is, the cage is given, find the number of ways in which all the letters of the word called person can be placed in the squares or rectangles of the given figure so that no rows remains empty. There are 1, 2, 3, 4, 5, 6 letters. You should cover all these horizontal rows, a number, insert there. It can be shuffled, how many number of that number of ways or permutation. So for example, if I show one letters chosen here, applying the cages, I put here R, here N, O, here I say P, E, and S. So totally every should be there. So 4 letters can be shown there for P, O, here, P, E, R, S, O, and every all one of this, I'm sure one of the pattern. So there are how many total types available. So don't leave a row empty. That's condition, right? So see how you complete this. Row 1, row 2, row 3. Here you will find the combinations also. Number of combination. That means N here, O there, O here, N there, or R can come this way. They can also shuffle itself. And number of permutation also here. It's combining the idea. So see, first row 1 letter, as I mentioned, second row another 1 letter, third row 4 letters, then totally 6 letters available. What the combination of these? See, first row 2 chances, 1 letter at a time. So 2C1, okay, 2C1 into second row also 2 chances, but 1 letter, 2C1. 4 letters in the third row. See, third row 1, 2, 3, 4 cages available. We insert all the 4 letters there. They are we call 4C4. So I hope you can simplify this formula, and CR means what? Factorial N over N minus R into factorial R, as we worked earlier that binomial problem also. And if you simplify, answer becomes 4, right? So 4 chance available combination. So they can shuffle each. That means I put R here, and now I erase the R. I take here R, and I take here E. I am showing one example there. So I show N here, I put the N here, and take this here. Possible, right? They can shuffle itself. There are 6 letters, they shuffle itself. That's why 4 times factorial 6. If there are 5 items, how many ways they can arrange themselves? Factorial 5. There are 10 words, A, B, C, D, E, F, like 10 words. How many possibilities they can change their positions? Factorial 10. Therefore, that's why multiple by that. It becomes 2880. And the chance. First row 1 letter, second row 2 letters, third row 3 letters, totally 6 there. So what the combination chance? First row 2 possible, 2 blanks, 2 squares or 2 rectangles available. Only 1 I want to insert, so 2C1. Second row 2 cages, 2 squares, 2 to be filled, and 2C2. Third row 4 blanks, I am using 3, only 3 letter I am showing there. So combination is what? 4C3. If you simplify, the answer becomes 8. Then they can change itself, their positions. They can go to the upper row. The person from the first row comes to the third row. They will change. And that's why 8 times factorial 6, like that, 5760. So similar fashion I shown clearly. You can watch this video the way. Last one, 2 rows The first row 2 letters, second row 2 letters, third row also 2 letters. Therefore 2C2 all cover. 2C2 is 1, NCN is 1. Here last one is 4C2, 4 blanks available, but I use only 2 letters, therefore 4C2. Complete answer 6 times, 6 combinations available like that, but they can shuffle itself all with the 6 letters person. Therefore 6 times factorial 6. Like this I shown clearly. So therefore total, if you sum with the answer, 18,720 is the number of ways. There's a condition, you can't leave a blank. Every blank must be filled, each at least a letter, at least 1 letter in cage, in the square form, shapes or rectangle. So I hope you understand this way. If you work, check with me. I fully tabular shown, but only for structured type can be asked in the future essay problems also. Here's a diagram provided, and that meaning of the diagram is the answer. Okay, next question number 6. That is complex numbers. So every papers what I completed earlier, I shown a complex number structured expectation. So here, draw a rough sketch of the complex number Z on an Argand diagram, the given argument. Before that, I show something about the argument. Is Z equal theta? I will explain few theory parts. What is argument? Is Z equal theta means what? That's the straight line segment which is makes positive from the positive direction of x-axis or the real axis angle theta. This is passes to the origin. If I sketch this like this, is the locus of the complex number Z on an Argand diagram, right? Like this, through the origin, right? And what happens if this argument Z becomes minus theta. If I take that side theta, here downwards theta, right? That's the meaning. Like something like this theta or this minus value, anti-clockwise, anti-clockwise, anti-clockwise here, right? That's the idea. See, another one argument is Z minus Z naught. Argument is Z minus Z naught alpha. Argument is Z minus Z naught is alpha. How is locus? See, actually, argument Z is what? If I expand that, is Z minus 0, think like that. You assume like that, think like that. Argument is Z mean, argument is Z minus 0. Therefore, passes to the 0 mark. Origin passes to the 0. So here what? Passes to the Z naught. Passes to the Z naught, right? We don't know where is Z naught, so random, that theory part I am showing here. So maybe like this. If I mark the point Z naught here, so line make with the x-axis, right? Always with the x-axis, otherwise parallel to the x-axis. Through this, along this line, the given complex number is Z lie. Here complex number is Z locus. Is that complex number lie along this straight line? Is the theory part useful to complete this problem, right? Later the modulus also I'll explain that later part. So now we sketch. Draw therefore rough diagram. Argument of Z is a moving complex number, therefore not known. Minus 3 minus root 3i, okay? The angle is shown minus 150 or 5 pi by 6 minus, therefore as I explained earlier, minus come, this is positive direction of x, it become other side downwards, right? So if you rearrange this part, According to the theory that you learned in the theory class, we complete that argument z minus what? 3 plus root 3i, is it? 3 plus root 3i. This is equal to minus 5 pi by 6. That's equal to minus 150. And now we roughly plot in an argon diagram. Therefore, how this complex number moving makes 150 degrees other side through this point. See, through this point's moving, right? Therefore, how to show that? Maybe I can mark this point somewhere here. The coordinates and the x real part 3, imaginary part root 3. This is the point. If I say P, that point. So the straight line makes minus 150. So if you draw the parallel to the x-axis, parallel to the real axis, so minus. So the answer comes downward, the locus comes somewhere here, right? Somewhere a straight line, this side, straight line. So if you make here theta, for example, mark theta, it's a straight line, you have gradient tan theta. This is 150, here 30. Tan 30, 1 over root 3, is it? Tan 30, 1 over root 3. See this coordinate also. Here y-axis root 3, x-axis 3. So in the primary work, how to find the gradient using the coordinates? Y-axis divide by the x-axis, or difference between the y-coordinate divide by the difference between the x-coordinate. That also becomes 1 over root 3. Now this straight line passes to the origin. Check that. The straight line passes to the origin. The straight line passes to the origin. Okay, here this is the 130. Here that we called minus 5 pi by 6. Therefore, this is the part, right? Locus of the z. Okay, study this important complex number easy chapter. The big problem there in the essay with the matrices. Also structure one question. This is the locus of the z. Decide how it's go through the origin, right? If you draw here 90 degrees, you can find remind that angle, see the tan theta type, or the gradient y equal mx pattern. This is drawn parallel to the x-axis. This is the first part is over, right? Hence, find the least value of the 2 modulus z bar minus 3i. Find the smallest value of such a modulus part. So what do you mean the modulus? I explained that argument earlier. Now I show the modulus. Mod z equal a. For example, mod z equal a is what? Mod means what? Distance from the origin. Mod z means distance from the origin to that particular complex number. That's equal to a. That's equal to a. Distance from that complex number from the origin. That is mod z, which is equal to a. A is a number. Therefore, in this case, we learn in the theory class, it becomes a circle because distance always same. It becomes a circle. How the circle? Center is the origin. Radius is this a, right? So here a, here minus a, here a, here a. Like that circle. So remember, therefore, complex number z lie on this line. So this I can modify like this. Mod z means z minus 0 equal to a. That's I told that earlier. Mod z means distance from the origin. So here easy. From the origin distance. So such a question comes, what the smallest and the highest answer of the distance? A. because complex number lie not inside the circle, not outside the circle. The complex number lie on the circumference. Therefore, z here. If you take the radius is 5, minimum value is 5, maximum also 5, because it won't go out, goes out of the circle, or it won't come inside the circle. They are very simple theory explained here. So z minus naught means what? Distance from the origin to that complex number. Distance from the origin to that complex number, very important. Now we change that problem. Now see, the z bar is a problem. How the z bar? Here we don't know what is z bar in this case. So something confused. Actually the problem is a problem here. Now we are rearranging what the given complex number pattern. We know the z. This is z. Z moving. Z is moving downward, not there. Z not moving the upwards. Z coming downwards, right? Z is moving downward because the angle is obtuse angle, downwards obtuse angle, right? Therefore, I want to recorrect this into our original Z pattern. We don't know what is Z bar. So see the method. I will simplify this modular symbol. Take the 2 out. Take the 2 out. Z bar minus 3 over 2i. Okay. Okay, that. So further 2 Z. See, if you know some that we call the complex number modulus theories, I can rearrange this. Z plus 3 over 2i. It's bar. Is it okay? Inside the modulus, or if I show the theory part, Z1 plus Z2 bar can be shown as Z1 bar plus Z2 bar. Okay, no, modulus not need, without that also is true. That side showing inside the modulus, right? Inside the modulus, I put completely bar. See, Z bar plus, but here minus. Why? This bar, you know, the bar of a complex number conjugates. Bar of the I is what? Minus I. If it's 2 minus 5i, what is the bar of that? 2 plus 5i. 2 plus 5. Therefore, bar of the I is minus I, right? Therefore, Z bar, is it okay? Z bar, okay? If you confuse of the I becomes minus I, this bar 3 over 2 I bar is, for a constant number there is no value of the bar. I bar of the I is minus I. Okay, that's the part. See, another thing, another form of a complex number inside the modulus, no matter about the conjugate. That means Z modulus equal to Z bar modulus. Note these points, right? Complex number Z equal to Z bar modulus. I can explain that. If you take Z equal 3i plus 3 plus 4i. If Z equal 3 plus 4i, what is mod of the Z? Square root of real part square plus the imaginary part square. 9 plus 16, 25, that is 5. That is 5. What is Z bar? What is Z bar? 3 minus 4i. What is its modulus? Square root of the real part square plus the imaginary part the square. Therefore, inside the modulus, no problem about the bar or not a bar, right? That we conjugate or without conjugate, no matter about that. So very important, this theory, if I use that, mod z equal to mod z bar, right? Okay, therefore 2, I can write the same as z plus 3 over 2i. Step by step I am showing. Very important, straight I can't jump to this part. So we will use the theory part, hands comes, right? Okay. I as I mentioned the locus here, we have the locus for what? Z minus Z naught, something alpha or A, like that. Z minus Z naught. As I mentioned very first, mod Z is 0 for A, mod Z is A. Why Z minus 0 equal to A. Study this. That's the distance from the origin to that particular complex number Z. Therefore, you need the minus symbol here, no positive theory part. So I change that to mod Z minus 3 over 2 I. Okay, very important. Study that. Z minus 3 over 2. This 2 not a problem, 2 ordinary number 2. What is modulus is, what the meaning of that modulus? Or distance from the origin, or distance from the complex number Z naught to the asking the complex number Z. Therefore, what the meaning of that? The distance from the minus 3 over to I. What do you mean minus 3 over to I means the complex number, non-complex number lie on the imaginary part, lie on the below of the y-axis. The distance from that to the complex number is Z. So if I mark that here, I take somewhere a point here, that point here, that's I take minus 3 over 2I, this coordinate minus 3 over 2I, from there's what the least, smallest distance. So smallest or the minimum or the least distance means what's? Perpendicular displacement distance. Therefore, I draw a perpendicular. This is the answer. So if I do something like L, if I say this value is L, you find that value. That's the answer. So what happened using the previous locus and last part? Why they asked to draw this locus? To find this distance because of the angle. What is this angle? Can you find the angle here? See, this is what 30 degrees. So here 30, okay. Here 30, corresponding angle lines are parallel, right? So here 30 means here 60 is it? Here 60, check that, here 60. So it's right angle triangle. You know the hypotenuse. 3 over 2. You don't know the, what you call opposite side. So use the trigonometric part, find the answer. Therefore, it's a very important question. I explained many methods, many theory part I explained here. Try to catch it, that method. Therefore, 2Z bar minus 3I minimum equal to what? There's a 2 here. There's a 2. 2 into Z minus 3 over 2I. It's minimum, is it? It's minimum, right? Check the copy, properly copy down these things. Therefore, the answer 2 into what is this distance? Which what is this sine theta? Can I sine 60? Is it sine 60? What sine 60? Sine 60 is it okay? L over 3 over 2. Is it 3 over 2? Yeah, L over 3 over 2. Therefore, 3 over 2 sine 60. Okay. 3 over 2 sine 60 is the answer. Very important. There's a 2. So 2 cancel. 3 into what is sine 60? Root 3 by 2. Sine 60 is root 3 by 2. So the answer 3 root 3 by 2 is the shortest distance from the given that locus of the complex number from that point to the required this from this point to the locus of the complex number, right? Nice question can be asked in the paper 1 or the part 2 also, such a locus types. Okay, next question number 7. Problem number 6, the coordinate geometry straight line. If x over c plus y over d equal to 1, be any line through the intersection of, yes, so what they say, there's a straight line, two lines cuts, two lines intersect, first show by diagram form. One line is, they said x over a plus y over b equal to 1. Another line is x over b plus y over a equal to 1. So the both cuts here, and the new line passes to that intersection point. The new line passes to this intersection point. The new line is given x over c plus y over t equal to 1. If the point is P, so simple question using a basic idea of the coordinate geometry of straight line. So what the idea? These two straight lines are cuts here. If you know the way how to calculate the coordinates of the straight lines that intersect, you solve these two equations. If you solve that two equation, you can find the x answer, also the y answer. That's the coordinate of the point P. If I mark those x bar, y bar, x bar comma y bar, the coordinate. If you solve this pair of equation, you can find that coordinate. Okay. Later we settle that if this straight line passes through the point P, if the given straight line x over c plus y over d equal to 1 passes through the given straight line, then what happens? This coordinate satisfies the equation. This x bar y bar satisfy mean what? X bar over c plus y bar over d equal to 1. That's the idea, you can get the answer. Therefore, first we find the x bar y bar coordinate, right? So x over a plus y over b equal 1. First equation. Other one, x over b plus y over a equal 1. Second equation. Now solve this pair of simultaneous equation. Find the values of this both x and y. I use some simple method. Substitute. If I take 1 comma 2, here see x over a, here 1 over b into y. What is y? 1 to what is y here? 1 minus x over b into this a. Okay, is that x over a plus 1 over b. Y means what? 1 minus x over b into a, right? That is 1. Now here you can find the x value, or I mentioned x bar, right? So solve this x over a. If I multiply the bracket minus, what is that? A x over, is it b square, something like that? Check that. And here what? 1 minus a over b. Okay. Now if I take the x value, x out, use the LCM, simplify, ab square, then here b square minus a. Okay, then check value. Here what? B minus a over b, a square. You can factorize this b minus a, b plus a. So b minus a cancel, 1b cancel here. Therefore, what the x answer? 1b cancel here. So if we cross multiple a b over, can I say a plus b? Is it okay? Check value. X is a b over a plus b. X coordinate is AB over A plus B. Let's go equal X bar. Find the same fashion, find the Y. That also becomes same answer, I think. Simplify same method. 1, 2. 1, 2 gives you, I find the Y answer, I put here Y over, let us try to take the X 1 over A, 1 over A, 1 over A, X, what is X? 1 minus Y over A into B, the first equation, I subject in terms of Y, put there for the X in terms of plus Y over B equal to 1, So if I rearrange what happened here, B over A minus by over A square plus Y over B equal 1. So the same answer comes, check, will simplify, becomes same solution, same coordinate, both equal. So if I rearrange, take the Y out, 1 over B minus B over A square equal 1 minus B over A. So simplify this Y, the LCM is here A square B, A square minus B, here A minus B over A. So 1A cancel with B square, check that. So factorize A minus B, A plus B, 1 cancel. So Y answer is 1A cancel, AB over A plus B, right? So both X bar, Y bar same. Now you can write a sentence. But this intersection coordinate passes through X over C plus Y over D equal to 1. X bar comma Y bar passes through what? X over C plus Y over D equal to 1. This is, I mentioned Y bar later, right? This I called X bar, the intersection coordinate in this my diagram. And now we apply, put X bar, what is X bar? 1 over C into AB over A plus B plus what is Y bar? 1 over D into AB over A plus B equal to 1. Now simplify, get that given expression form. Now multiple A plus B, divide by AB. 1 over C plus 1 over D equal A plus B divide by AB, is it? So what is that? 1 over C plus 1 over D. Write separately, divide separately. A over AB, A cancel. 1 over B. B over AB, B cancel. 1 over A. That's the answer, right? 1 over A plus 1 over B equal the same 1 over C plus 1 over D. Okay, next question number 8. Next coordinate geometry of circle. I hope you work these things, so check with me. So best thing I will publish my applied structure paper. You try your own, whatever, no problem. You will refer your theory notebook, any tuition class notebooks or any rough past exam paper. Try that. Then the teacher explain like this, you will feel better than the other ordinary by copying the answers. So here, if circles x square plus y square minus 10x plus 4y minus 20 equals 0. Another circle x square plus y square plus 14x minus 6y plus 20 equal to 0. Okay, 22, 6y plus 22 equal to 0. Check the equation properly. X square plus y square minus 10x plus 4y minus 20. Other one, x square plus y square plus 14x minus 6y. Yes, if the circle touch each other, okay, they both touch each other. If I draw a diagram like this, touch each other at a comma b, this coordinate a comma b, is it okay? Both touch this a comma b. I'll mark here a comma b, they touch. How you know this diagram? Maybe this also. Maybe they touch like this. This also a comma b. There are two touches, internally and the externally. Both satisfy, we don't know where touch. But we can determine properly, is this figure or that figure. That means internally or external touch. There's some condition that I hope you learned the theory class. Okay, then there we show 13 something, the b minus c that. Okay, so when we work the circle problem, we need the center of the circle and the radius of the circle. So if I say this circle center is C1, what is C1 coordinate? Have you learned? If a circle equation becomes 1x square and 1y square, to find the center coordinate, divide the x coefficient by 2 and change the symbol. 10 divided by 2 is 5, minus 5, change the symbol, plus 5. How the y coordinate? 4y divided by 2, 2, change the symbol, minus 2. This is the center one, this circle center, right? Also write the radius R1. How to find the radius of a circle? Square root of the center coordinate squares minus constant term. Okay, this equal generally g square plus f square minus c. So a 5 square 25 minus 2 square plus 4 minus 20 plus 20 therefore. So what the answer radius, to simplify, 20, 49, 7. Radius of this circle is 7. Follow same here, come this circle. What is center? C2, I say C2, here C2, right? Here C1, this is C1, here C2. What is center 2? Minus 7, comma 3. What is radius 2? Square root of 49 plus 9 minus 22. So what is the answer? Simplify this. 36, the 6 is it? Check with you. The radius of these two circles, that is 6. So still I don't know if internally or externally. Now we check. See, this radius 7, this radius 6. Therefore distance between the center 13. Okay, if it's touched like that, if it's touched like this, distance between the centers 13. I am showing now not only for this problem, any other future these ideas. If they ask the question, tell that or check that whether the circle touches internally or the externally. That's a problem. Not this question, if they ask so in the future. So now centers, distance between the centers is 7 plus 6, 13. Also you find your ordinary straight line knowledge, the distance between the C1, C2. What is C1, C2 distance? What is C1, C2 distance and C? Your distance theory, x1 minus x2 square plus y1 minus y2 square. So that here 5 plus 7 square plus minus 2 minus 3 square, is it? So additional part here, this question you are show this, you can't go to the answer without this. Without this your answer is wrong. I think every students, every subscribers, you must work this. So you got 144 plus 25, 169, so 13. Distance between the centers also 13, which is equal to sum of the radius. They are right below. Therefore, the given circles touches externally. Therefore, given circles touches externally. Very important. Without that, you can't complete the problem, right? You don't know it's touched the internally or externally. Therefore, given circle touches externally. Okay. Now see simple. So if I mark the C1 here, C2 here, both touch here, there's a coordinate A comma B. If I say point is P, you know this is 7, 6. You know this coordinate 5 comma minus 2. This, oh, see this diagram, you can see this diagram, right? Here what, minus 7 comma 3. So now there's a simple equation, the algebraic expression for term A, B. So you find the A value, find the B value. That also a straight line knowledge. The ratios, no ratios, internal divisor. How to find the coordinate of the middle point, somewhere point inside. So what is A answer? A is what? 7 into that x coordinate plus 6 into this x coordinate, is it? Or what? Sum of the ratio, is it? So 13, you can multiply 13A here. Minus 49 plus 30. Is it okay? Check with you. 7 times minus 7, 6 into 5, right? So what is that? Minus 49, that 19. 13A is 19. Now find the B coordinate. Same fashion, find the B coordinate. How the B coordinate? B is what? Same idea, y values minus, oh, is 7 into 3 plus 6 into minus 2 over 7 plus 16. So cross multiple, 13B equal to what? 21 minus 12, what is that? 9. So what is the question? Therefore 13B minus 13A. Is it 13B minus, I missed somewhere, the minus here, minus 19. Check will you, minus 19. 13B minus, what the answer? 28. Check. Answer is 28. Answer is 28. Okay, very useful coordinate geometry, both of that straight line and the circle. See question number 9, problem 9. So as I mentioned the previous many pure maths model papers, when I discussed, when I showed here, I shown the type of the, let's call it integration application, area under the curve. In the guide, teacher's guide, basically when you come to the advanced maths, when you teach these things, they said to show the student the shape of the diagrams. The parabola, what the shape, hyperbola, how the shape, ellipse, what the shape, and e to the power x graph is how, logarithm graph is how. That is not necessary using the dy. You know how to draw the sketch by calculus method. Find the dy over dx, tell the maximum or minimum, find the asymptotes and approaching something, and draw the curve, maximum curve, turning point curve, or sometimes we have no maximum, no minimum. They call point of refraction types, inflection points. So here not need those things strictly you have to draw, you can draw. Sometimes diagram is available in the question paper script. Otherwise roughly you have to sketch. So as I mentioned last video also, here also I show you briefly some pattern of the shape of the graph and how these vary. So in this case, see very first, y equal e to the power x graph, right? Y equal e to the power x. Note this, very important, I can't show every time these things. So note this, y equal e to the power x shape like this. If you put y-axis coordinate is you put x for 0, y is 1. If you have doubt, you use your calculus dy over dx method, you can draw this graph. It becomes like that, y equal e to the power x, okay. The graph y equal e to the power x shape. Now I show the other one, y equal, the second diagram, y equal minus e to the power x. So I am giving not only for this problem and future ideas, right? What is y equal minus e to the power x? What happened? This is positive e to the power x. Minus become like this. About the symmetric about the x-axis, right? Symmetric about the x-axis. The graph symmetric about the x-axis. Not these graphs like this. So see it goes somewhere 1, here's come minus 1. Symmetric about the x-axis. That is y equal minus e to the power x, right? Y equal minus e to the power x. Okay, next see third diagram, I show you y equal e to the power minus x. That's the graph you need this question. That's the graph you need this question. Y equal e to the power minus x. Y equal e to the power minus x. Here positive x come like that. Minus x come other side. That is symmetric about the y-axis, right? This goes like that. Minus come this side. Like that, y equal e to the power minus x, right? This is becomes 1 here. That is becomes 1. Therefore you can draw what happened is minus times e to the power minus x is downward. Fourth diagram. X-axis y or the origin. So it becomes cut this side, right? That's the shape. It comes down like that. So this become minus 1. This become minus 1. That is becomes minus 1, right? That's the graph. We need this question also. We need that y equal, what is that, 3 minus s. So the idea is very important. Is what? Y equal minus e to the power minus x. For diagram, not only for this question, in future also it's very important graph, right? Now you see, from this if I explain another graph from this, I can mark number 5. Y equal e to the power x plus 2. Think about that. E to the power x plus 2. So what happened, the simple idea of mathematics, the transformations, if it's 1, it goes 2 part above, 2 unit up, added 2, no? There it goes to 3. You can roughly draw that also. 3. E to the power x plus 3 becomes upward 3. If it comes, for example, minus 2, it comes down. So everything the same idea, right? For example, you can try e to the power minus x. If it's plus 4, what happened? Upward at 4, minus come, go down. Same thing, very useful explanation, not only for this question, but also some other part in the future, right? Okay, now we check that question. Sketch the graph of the fx and the gx. Everything explained, the pattern now I hope you can draw roughly, no any differentiation pattern. This is the area under the curve. Also now you have the area under the volume from 2019. They once again implement in the syllabus. Right. So when drawing, the intersection points are important. You have to mark clearly the coordinates of the intersection. Then everything is clear, right? So first graph f of x equal 3 minus e to the power minus x. So as I mentioned earlier, one of my rough diagram earlier, very clearly, I shown the e to the power minus x. Next I shown the minus into that. Next added 3, then you know how to draw. Also the other graph is what? G of x. G of x is 1 plus e to the power minus x. 1 plus e to the power minus x, right? Okay, now we can plot the both diagram on one sketch. Both mark in one sketch. Especially we need the coordinate x's, right? Coordinate intersection. How the fx graph, see that here the fx graph added 3, so like this. Is it the graph? Here 0. Check this e to the power. Check the e to the power minus x, check that one. And plus 3, what happened? Here it was 1, 3 units more. Therefore I think this becomes 2. Check will it become 2. Okay. It becomes 2. And how the g is, check the e to the power minus x graph, check value. It was cut in the y-axis at 1. Another one, that also 2. That also 2 passes that 2. Yeah, it becomes, see like this. I'm roughly showing this graph. Is it okay? This is fx. This is dx. Okay, the both cuts along the y-axis at 2. Okay, so what the question is, find the volume of the solid body which is formed by rotating the area lies in the first quadrant. Only here we have some part, here also we have some other parts also. Only first quadrant they ask. Rotate the area first quadrant bounded by the above 2 curves and the line x equal 3. Somewhere x equal 3. So which area? Which area they ask the volume? The bounded by these 2 graphs and with this straight line. Where the area? Where this? Is it this area? Is volume under the curve. When it rotate this, rotate by 2 pi radians, otherwise 360 degrees, volume generated. There's a formula to find, but the formula integral pi y square dx. Integral pi y square dx. Here it's a bit complicated. First we find the large area, large volume covered by fx curve. First we find large volume covered by the fx curve. That means this equation, right? This part also including therefore. Keep that answer separate. I say V1. Next you find the volume covered by this curve, under this curve, gx curve. That is only this. So you know the largest volume V1. Also, you know the small part below the blank volume. So what the answer? V1 minus V2. Okay, find the large volume, subtract the other volume. That's become the answer. Okay, right. So if I take that like this, I write here volume, required volume equal to V1 minus V2. Okay, V1 minus V2, right? First I complete the V1 part. V1, what is V1 equal to integral pi y square dx. So those not complete this lesson in my lessons or my tuition or this school, no problem. You copy this and you practice, then simply you can answer that day, that exam day you can cover this part simply. Pi y square dx. So also we have boundary from 0 to 3, right? 0 to 3 here. So take the pi is a constant. I write this pi is a constant part. What is y for the first curve? What is v1? I said the big one is the v1. What is the y? This 3 minus e to the power minus x. Its square into dx, right? This is 0 to 3. That is 0 to 3. Okay. So pi into integral, I expand this bracket a minus b all things square, 9 minus 6 e to the power minus x plus e to the power minus 2x, is it? Okay, check will you? Dx, the boundary is 0 to 3. Before integrating, that is enough. Now we come to the V2, right? Now come to the V2 and simplify that. I write here what is V2 equal integral, same formula. I can take the pi out, y g, here is the y, right? 1 plus e to the power minus x square, boundary 0 to 3. Boundary 0 to 3. So what is that? Pi into 0 to 3. I expand this 1 plus 2e to the power minus x plus e to the power minus 2x into dx, right? So you know v1, you know v2, therefore first we find the answer. Just bring a shade, this the answer they asked, right? Different between those v1 and v2. Therefore I write down this, find the v1, v2. Therefore v1 minus v2, right? Therefore v1 minus v2. v1 minus v2. So you can subtract because the same boundary, you can subtract that part. Pi into subtract here, what happened? 9 minus 1, 8. And here minus 6c, subtract that minus 80, minus 8 e to the power minus x. And here what? E subtract, cancel, is it? That cancel, I think. Check, will you cancel, right? Only there into dx. Into dx, boundary 0 to 3. Now use your simple basic here. Integration area under the curve or volume under the curve. They want us the big integration part, small integration you need. So we integrate now, see pi. Can I take the 8 out? 8 also take out, right? So integrate, yeah, 1 integration is x minus e to the power, integration is e to the power. And next one, power in differentiation is minus 1, right? The reciprocal become plus 1 here, okay? Boundary 0 to 3. So I think the answer is given, answer is given, show that pattern. So what is that? 8 pi, now write the upper boundary minus lower boundary. Put x for 3 plus e to the power minus 3. Okay, upper boundary minus put the lower boundary x for 0 plus e to the power 0 is 1. So therefore I hope you will work already. If you followed those my past 3 videos, I mentioned such a questions, area under the curve, volume under the curves. Then you have a good idea if you frequently watching my this explanations and all my videos. So 8 pi out, check is it okay? 2 plus e to the power, check is it okay? The answer there, yes. Such a volume we call cubic units, right? Cubic units, that's the answer. Right, come to last question. 10th problem. Practice this not only now, not only this video, you will practice many times this type and think how in the future problem you can expect in this exam, A-level exam papers. Question number 10. There's some trigonometric part. Find the value of cos 2x, right? They say 2 sine square pi by 2 cos square x equal what? 1 minus cos pi sine 2x. A nice question for trigonometry in any exams. That means by solving this given equation, find the what cos 2x or cos 2 theta pattern. Also they said x is not a what? Odd multiples of pi by 2, right? That means x not 3 pi by 2, x not 5 pi by 2, x not 7 pi by 2, not equal to odd multiples of pi by 2 only. This equation is valid. That's the meaning. This equation is valid for that. Okay? Right. So what's the idea? So sine 2x available. They ask the cos 2x. I think you can change this also into sine pattern, double angle formula. As I mentioned one very earlier question, cos 2 theta pattern. What is cos 2 theta? Cos 2 theta is what? 1 minus 2 sine square theta. So think if you change this, it's like a theta. It's like a theta. It's like a theta, right? If this is theta, think that it's all like a theta. So 1 minus cos theta form there is. So 2 sine square pi by 2 cos square x, right? Cos square x equal, what is double angle? 2 sine square, this half, so pi by 2, completely half, right? Let me take the half out. Is it check, will you? Is it okay? Pi by 2 sine 2x. Therefore simple, 2 cancel. So sine square equal to sine, so you can take the square both sides, sine also cancel. That's why they say x not a odd multiple of that pi by 2, right? So you can take the sine square out. So pi by 2 cos square x equal, pi by 2 also cancel, right? Sine 2x. They become cos square x equal to sine, nothing. It's like a grade 12 part, right? Nothing much more in this question. Cos square x equal. Can I change the sine 2x is 2 sine x cos x pattern? 2 sine x cos x, 2 sine x cos x, 2 sine x cos x. Okay. Now I show here. Take the cos x out. Take the cos x out. It becomes cos x minus 2 sine x. Is it okay? Equal to 0. Therefore, cos x equal to 0 or cos x minus 2 sine x equal to 0. But they said x not equal to 2 and plus 1 pi by 2. Therefore, you can't take x is 90. You can't take x is 90 or 3 pi by 2 or 5 pi by not valid. Huh? So here we won't take this part. We won't take that part, right? Take a note, very important. So here you can find the tan x. Solve, get it. What is the cos x equal to sin x divided by the cos x? Tan x is half, is it? Okay, take the tan x is half. There are a simple question, tan x is half. So question is find the cos 2 theta, cos 2x. So you know the tan cos 2x in terms of tan 1 minus t square over 1 plus t square. Therefore, cos 2x equal 1 minus tan square x over 1 plus tan square x. So put tan for half, tan for half. I hope you can simplify. The answer become 3 over 5. Nice question, well balanced problem for a structure type or part of the essay, first part like that. So very useful pure maths paper. You decide now what's your marks. Where are you in the pure maths section, especially structure type question. Have you covered your syllabus or part? How just all 10 problems are difficult or easy or medium or patta problems with the anyhow practice. I will distribute many supply many video through this platform, YouTube platform. Keep in touch. So new subscribers, better you subscribe these newcomers with the press the bell sign, then automatically receive all my things. The parallelly I am showing already the vectors completed and limit revision there, and reminder theorem for juniors and model papers also, right? You can forward this to your friends, classmates, colleague, or any all over the lives in Sri Lanka. No matter, I do some extra work through this platform. Zoom or Google Drive problem, you can refer one later, that is only that time only with the powerful what we call data, good Wi-Fi or mobile data available. Only that time you can view the Google or classrooms or the Zoom. But YouTube, very easy, everywhere you can adapt on it, you can go with that, anytime you can refer it. So therefore take full opportunity of this my video series.